I briefly wanted to talk about the difference between rational and irrational with sums and products. So if you look here, with this first equation, the reason that this one is irrational is because the square root of 3 and the square root of 7 are not perfect squares, therefore they cannot be simplified. In number 39, the square root of 4 is a perfect square, but 6 is not, therefore it cannot be simplified out of a perfect square, or out of a radical, and therefore it's irrational because it would be a never-ending decimal. For number 40, the square root of 9 and the square root of 25 are both perfect squares. The square root of 9 is 3, and the square root of 25 is 5. Therefore, this is a rational sum because I would no longer have a square root in my answer. Number 41 is rational because the square root of 4 can be simplified. Number 42 is rational because the square root of 4 can be simplified, and the cubed root, notice there's a cubed root. The cubed root of 8 can also be simplified. That would be a 2. So this is 2 plus 2, that equals 4. Therefore, rational. Now we look at multiplication. So when you're multiplying, remember that you're allowed to multiply what's underneath the square roots. So for this first one, you could simplify this and say that this is 2 times the square root of 21. But the square root of 21 is not a perfect square, therefore this is an irrational number. For 44, both 4, radical 4 and radical 9 are perfect squares, but I could also show it by multiplication. I'd have 2 times the square root of 36, which is 2 times 6. Therefore, that's a rational number. The square root went away. For 45, if I multiply 3 and 4, I get the square root of 12, but I cannot simplify the square root of 12, so therefore that is irrational. For 46, I have the square root of 8 times the square root of 8, which is the square root of 64, which can be simplified to 8, therefore rational. We talked about this one in class, but if you were not in class, then maybe you did not get a chance to see it, so let's talk about it really quick together. It says a function has domain from negative 5 to 10. So if I plot negative 5 to 10, negative 5 to 10, oops, and it says it has a range from 0 to 100. So anything that's inside of this dotted area would be good to go. So let me so anything in that little white shaded region would be a perfectly fine answer. But anything outside of that region would be not okay because it would either be outside of our domain or outside of our range. It also tells us that f of 2 equals 10. So that's somewhere around here, 2 comma 10. And it tells us that f of 10 equals 50. That's somewhere around here, 10 comma 50. And it asks which of the following could be true. The first one, f of 1 equals 15. I'll do my points in red. F of 1 equals 15 would be somewhere around here. That's good to go. That's in my little shaded region, so that's a correct answer. F of 0 equals negative 5 would be somewhere around here. Notice that it is not in my little shaded region. It's too far below my range. My range starts at 0, and negative 5 is below that, so that would be a wrong answer. The next one is f of negative 5 equals 0. Well, yeah, that's right on the cusp, but it's good to go. It's on the corner, and we can say that that's a correct answer, so we're good to go there. The next one, f of 9 equals 150, would be somewhere way up here. Notice that it's too tall for the range, so we have to cross that one off. It's way outside of my range. The next one, f of 20 equals 30, is actually outside of my domain. That would be somewhere over here. F of 20 equals 30, not in my shaded region, therefore it's outside my domain. The last one's a little tricky and thought-provoking. F of 2 equals 90 is technically inside of my domain, but it is actually not a correct answer because we already have another point at 2. We have the point 2 comma 10, and you're not allowed to have 2 points on the same line. So this would make it so that it's not a function because it would not pass the vertical line test. So therefore we say even though this is in the domain and range, it wouldn't make our graph a function, and it says it has to be a function. So we cannot say that that's an answer either.